Hi class, our first topic of week 4 is systems of equations. We've already dealt with systems of linear equations. If you remember, we were always trying to figure out where they had a common intersection point. We learned a couple different methods on doing that. We learned how to graph two lines and figure out where they cross. We also learned the substitution method where we would plug in one of our equations into the other one for a specific variable. And we've also learned elimination where we had to put them into standard form, both of our linear equations into standard form, and then solve for the variables. Today and this week, we are talking about both linear and quadratic systems. So no longer just dealing with two lines, we'll have a parabola, as we can see on this left-hand side, and then we'll also have a linear equation. So same goal in mind, we're just trying to figure out where both of these functions have a common point, a common solution. And as we remember from the graphing method in linear equations, that happens where those two functions intersect each other. So today during this lesson, this is the first video that you guys are watching from the county. We are going to be able to solve a linear and quadratic system of equations, both graphically and algebraically. All right, so first little part of our video that you guys are watching before this is the different types of solutions. So as we just talked about, our solutions are where our two functions are going to intersect. So we have three different cases that could potentially happen when we are doing systems of equations with one quadratic and one linear function. First off is our linear function could intercept our parabola in two different locations, right? It crosses the parabola there and there, therefore there are two solutions. Remember, our solutions are where those two equations intersect. Another case that we could have is if our parabola kind of comes down and kind of just kisses our linear function in one spot and then bounces right back up. In that case, it would just be one solution. It only intersects in one spot. And then lastly, as you can tell over here, our two functions don't even intersect at all. They don't touch. This parabola is above my linear function there. Therefore, there is no solution, no intersecting points. All right, so just be aware, every time you do these problems, you don't always have two answers, right? You could also potentially have just one solution. You could also potentially have no solutions. Graphically what that looks like down here. First couple of questions here, it just wants us to determine how many solutions there are to the system. So looking at this first graph here, I have a parabola that it doesn't look like it intersects this linear function at all. So the number of solutions here is there are no solutions because there is no intersection point. Our next one right here, we have a parabola, comes down, kind of just kisses my linear function in one spot. Therefore, there is one solution. And then, as we just discussed earlier, the last potential scenario is if my parabola intersects my linear function in two different locations. Therefore, I have two solutions. So looking at a graph and trying to figure out how many solutions there are, not too crazy. It just gets a little bit more complicated when they just give us the equations and we need to figure out using algebra what those two or one or zero solutions may be. All right, so let's jump right into an example. The first example they gave you guys is this one right here. I have two different equations. First off, let's just take a little bit of notes right here. The first equation, y equals 2x squared plus 13x. I know that this is a quadratic equation because it has the x squared term. My largest degree, if you remember what that word means, degree is the largest exponent, is a 2, therefore I know it's quadratic. Down here, y equals a negative 6x minus 9. That is a linear function because my x variable, the exponent is just a 1. That's why we don't see it. Therefore, it's a linear function. All right, so if you look down on the notes that was provided to you, it tells you the steps that we're going to be taking. So I'm going to read these, and then we're going to go back up and solve example number 1. So the first thing we want to do is we want to substitute y in one equation with that in the other equation where it says y equals. That's just a fancy way of saying we're going to use the substitution method, right? That's why it's using that word substitute. All right, we're going to set the equation equal to 0. What this means, if you want to take a note of this, this just means put into standard form. Put into standard form, which we know is ax squared plus bx plus c equals 0. That's just a fancy way of saying getting everything on one side of the equal sign. And then we're going to solve for x. We are going to do this. We're going to factor, right? So we're going to factor to do this. You could also use the quadratic formula, but I believe the video is going to go through the factoring method, which some of these might not be factorable. So we'll kind of play it by ear. Sometimes you might get into a situation, especially if there's no solutions, that it's not factorable. So always do whatever method you think is best. Quadratic formula will work every single time. Factoring only works on certain cases. And then lastly, it says we're going to substitute the value of x back into either equation. It doesn't matter which one, pick the easiest one, and then solve for y. All right, so we're going to go through example number 1. We're going to solve these problems, and then I'll show you an example in which we're using the factoring method and in which we're using the quadratic formula, just so you guys have a good idea of which methods you could use. All right, so coming back up here, first step is to substitute one of my equations in for the y. So what I'm going to do is I am going to take this negative 6x minus 9, and I'm going to rewrite the top equation, but where I see that y, I'm replacing it with the negative 6x minus 9. All right, so over here, negative 6x minus 9 equals 2x squared plus 13x. So all I did was I substituted the first y in my top equation with my entire second equation. All right, step 2 down here, it says set the equation equals 0. That's a fancy way of saying put it into standard form, which just means get everything on the exact same side of the equal sign. So it doesn't matter if you move things to the left or to the right. I like to keep my a value. Remember, a is always the coefficient of x squared. I like to keep it positive. It doesn't really matter. It's just a personal preference. So I'm going to move both of these terms over to the right. All right, since they're both negative, I'm going to have to add both of these terms. All right, those are inverse operations, so they're canceling out. What you do to one side, you got to do to the other. So I'm going to add 6x over here to its like term. And I don't have a coefficient, or excuse me, I don't have a constant over here on the right side. So I'm just adding 9 to the 0 that was already right here. All right, once I do that, I'm left with a 2x squared. 13 plus 6 is a 19, so I have a 19x. And then 0 plus 9 is 9. Okay, so now this is the quadratic that I'm dealing with. So my whole goal now is I want to take and I want to solve for x. So this is the part where you have a choice. If you're really good at the quadratic formula, plug it into the quadratic formula and solve for x. If you'd rather practice some factoring, which we're going to do in this example, then you can try factoring. Just remember, factoring does not always work. So if you get down to a scenario where you can't find the two numbers that multiply to get AC and add to get B, try going back to using the quadratic formula. All right, so what we're going to do, I'm going to use the factoring method. I'm going to go down here and I'm going to label A, B, and C. A, B, and C. A is the number attached to x squared, B is the number attached to the x value, and C is that constant. All right, remember we did this x box thing, and we put the AC number up top here, so 2 times 9 is 18. And remember, B goes on the bottom, so I'm putting 19 down here. All right, and then I'm looking for two numbers that multiply to get 18, but those exact same two numbers add to get 19. So worst case scenario, you're coming over here, you're making that T chart, and you're just labeling numbers that multiply to get 18. So 2 times 9 is 18, but when you add those together, you get 11. So I know that cannot be the answer. What else? We have 3 and 6. Those multiply to get 18, but they add to get 9. I'm looking for the two numbers that when I multiply them, I get 18, but when I add them, I get 19. So let's try 1. 1 and 18, that is the 19 that I'm looking for. So that 1 and 18 are gonna go right here. I like to box them off just so I know what I'm looking at. All right, we're coming down here. We are going to make that open rectangle, that garage looking thing. We're gonna put the 1 and the 18 down here. All right, remember on top goes my AX. ax. A in this case was a 2. So I have a 2x and a 2x. And then I'm going to look at these two guys individually, and I'm going to pull out that GCF. All right, can't pull out a GCF here, so 2x plus 1 just stays right there. Here, what I can do is I can pull out a 2. All right, if I pull out that 2, I'm left with an x plus 9. Right, I can divide this by 2, I can divide this by 2, 18 divided by 2 is 9, 2x divided by 2 is just x. Always double check. If you want to, you can go through and FOIL this. If you FOIL this, you get right back to this answer right here. All right, so not quite done yet. I'm still solving for x, so I don't have x quite by itself. So I want to do that zero product property. I'm going to take 2x plus 1, set it equal to 0. Take x plus 9, set it equal to 0. I want to get x by itself. This one over here on this right side, a little bit easier, so subtract 9. I get x equals a negative 9. I'm just going to kind of box this off for now. It's not my final answer. I'm just kind of making sure I know where it's at on my paper. Over here for this one, subtract 1. Sorry, I'm running out of space. I get 2x equals a negative 1. Sorry, you can't really see that. 2x equals a negative 1, and then let's divide both sides by 2, and I get x equals a negative 1/2. All right, so I'm going to write that over here. X equals a negative 1/2. We are almost done, right? That is not my final answer because I still have that last step that I need to do. I just got done solving for x. I know x equals negative 9, and I know x equals a negative 1/2. I'm now going to plug those values in for either one of my two original equations, and then I'm going to solve for y. All right, so I'm going to use it in this little white space up here. This is where I'm going to write my final answer at. So I'm going to take my second equation just because it's a lot easier. It's a linear function. I would definitely recommend always plugging it into the linear function. So I'm going to write y equals negative 6, and I'm going to substitute in my x value that I just found, which was a negative 9. I'm going to do that one first. And then minus 9. And then let's go ahead and do this math here. Right, using our finger trick, we know that negative 6 times a negative 9 is a positive 54. And then 54 minus 9 is a 45. All right, so one of my solutions is negative 9, 45. Remember, our answers are a point in which these two equations are intersecting. All right, that's one of my solutions. And then my second solution here, I'm going to use a different color marker. I get y equals negative 6, and I'm now plugging in a negative 1/2. And you guys can use a calculator if you need to on this. A negative 6 times a negative 1/2 is a positive 3. 3 minus 9 is a negative 6. So my other solution is a negative 1/2, comma, negative 6. That's a 6. And then this is my answer. There is where, if I were to graph both this quadratic and this linear function, these are the 2 points in which they would be intersecting. All right, guys, I want to go through and do just one more example with you guys. You guys have 2 examples left, but we're going to do just one, and I'm going to show you how to use the quadratic formula. This was a lot of work. This factoring is a lot of work. If you guys are getting comfortable with the quadratic formula, which I really, really hope you are, it should be much quicker and a lot less different strategies to help you. You're kind of just plugging and using your calculator to help you simplify things. Okay, so let's pull up that next example. I'm going to do example, this is also example number 1, poorly titled here, but example number 1. All right, so if you notice, I have y equals x squared plus 6x plus 9. I know this is my quadratic equation because it has the x squared. And then I also have y equals x plus 3, which is my linear function. So going back to those steps, always use your notes to help you out. My first step, substitute y in one equation with what the other equation says for y equals. That's a little bit of a confusing way to say. I'm going to take this x plus 3, and I'm going to substitute it in for this y. Excuse me. All right, so first thing, I get x plus 3 equals x squared plus 6x plus 9. All right, second step, going back to reference my notes here. it says set the equation equal to 0, which in a fancy way, put it into standard form. Get every term on the exact same side. All right, my preference, I like to keep my x squared term positive if I can. So once again, I'm moving both of these terms over. Since it's a positive x, I subtract it. Since it's a positive 3, I subtract it. What I do to one side, I have to do to the other. X squared is going to stay as x squared. 6 minus 1 is a 5x. And then 9 minus 3 is a positive 6, right? We're setting that equal to 0. Everything is on the exact same side of the equal sign. All right, this one is factorable. It is. But I'm going to show you how to use the quadratic formula to help you solve for x. So right now, when it says, in my example, it does say use the area model to factor. We actually used a different method that we taught you guys in class. But you know what? I'm going to show you guys how to use the quadratic formula. You can do either method, whatever method works best. Since we just got done doing the quadratic formula, I'm guessing this is hopefully a little bit more fresh in your minds. All right, so we get A equals 1, B equals 5, and C equals 6. All right, I'm using the quadratic formula. So x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. Right, I'm going to plug in my values here. All right, so I get x equals the opposite of b. B is 5, so in my formula, it appears as a negative 5, plus or minus the square root. And now every other letter or variable that I'm replacing, I'm putting my number in parentheses. So I have b squared minus 4 times a times c all over 2 times a. All right, first step, always plug those numbers in. First thing you want to simplify once you get here is you want to simplify that discriminant. This is going to tell us how many solutions we have. So if we ever get a negative number here, right off the bat, I can say there's going to be no solutions. All right. Okay, so I'm going to take this in. We can use our calculators, which I have a calculator somewhere on my desk here. Maybe not, maybe not. Oh, here it is. All right. So we have, and I'm typing it everything under the square root. Do not type in the square root. So I got 5 squared minus 4 times 1 times 6. And I get 1, right? So this thing simplifies down quite nicely. It's going to be x equals negative 5 plus or minus the square root of 1. And then let's clean this up. 2 times 1 is 2. All right, now I'm going to take the square root of my discriminant. The square root of 1 is 1, right? 1 times 1 is 1. All right, so furthermore, this goes into negative 5 plus or minus 1 over 2, which I now can simplify and break this down into my 2 different problems here. One of them is going to be negative 5 plus 1 over 2. That's going to give me a solution. And then I'm going to get negative 5 minus 1 over 2. All right, do the numerator first. Negative 5 plus 1 is a negative 4. Negative 4 divided by 2 is a negative 2. That's one of my x's. All right, negative 5 minus 1 is a negative 6. Negative 6 divided by 2 is a negative 3. That is my other x. Last step, I just have to go back now, take both of these answers, plug them into one of my 2 original equations and solve for y. In my opinion, the easiest one is always the linear. So I'm gonna just do a little dividing line here. I get y equals, I'm plugging in my first x value, which is a negative 2. And this gives me 1. So one of my answers is going to be negative 2, comma 1. That is one of my intersecting points. All right, my other one is going to be y equals negative 3 plus 3. And that gives me 0. So the other intersecting point is negative 3, comma 0. If I were to graph both of these equations on the same graph, they would intersect at both of these coordinate locations. All right, guys, watch the county video. They go through example number 2 with you. See if you can do it on your own first. I know the directions say to factor it, and that's how the video is going to show it to you, but if you feel more comfortable using the quadratic formula, that is the method that I would choose. Do whatever makes you guys the most comfortable and the most confident. All right, guys, I'm going to be posting another video here in a couple minutes, but please email me with any questions.